So here is Mr. Poovarasan, who is a senior team leader from R&D ADAS System Engineering, ZF Commercial Vehicle Solutions. He holds an undergraduate degree in the field of automobile engineering, and he has a diverse experience with multiple OEs and Tier 1 organizations with more than 15 years of experience in development and testing expertise. He focused on heavy commercial vehicles control systems. He is currently leading a 15 plus R&D team at ZF Commercial Vehicle Control Systems India. His team primary focus on developing the cutting edge ADAS features like automatic energy braking, automatic cruise control, driver drowsiness warning, and intelligent speed assist for European and Chinese markets. He is a long-term standing member for our SA team. I'm proud to say that. Thank you, sir. And he is also accredited, certified IATF internal audit with a unique eye for innovation. He is also a leader for driving innovations beside the ADAS team. He has personally filed 2 patents, which are in the final stages of getting awarded. So I'm really
thank you.
It's an honor to welcome you, sir.
Thank you. Pleasure is mine. So again, good morning all. So today I will be explaining about the ADAS, Advanced Driver Assistance Systems, and its technology trends in India and throughout the world. So before starting the presentation, maybe it could be easier for you to have been stay back in the hostel or home on a lazy Saturday morning by watching Netflix or Prime, but instead you choose to attend the event. Thank you for that. Thanks for being here. And of course, back then in college, I think I can say this to the students, especially even though you could have studied well when you were writing the exam, suddenly when your professor, you could have studied well and you are writing your exam. In the exam hall, when professor comes and stands behind you, you feel a little bit nervous, right? So that's how I feel now when I have my mentor and inspiration, Dinesh is here. So thank you, Dinesh. It's a honor and it's a pleasure attending this event. So now, since you are here, it's my responsibility to make sure the next 30 minutes I'll give you some engaging and interesting content in ADAS trends. Yeah. So, so what is the push for ADAS? I hope you are aware what is meant by ADAS, Advanced Driver Assistance System. Like when we talk about ADAS, most people will directly jump into a thought that it is an autonomous vehicle or a semi-autonomous vehicle. It's not that way. I mean, there is a very big transition for moving from conventional to ADAS technologies, which we cover today. But what is the push for those ADAS technologies? Basically, when I am from Commercial Vehicle Solution, I prepare the presentation in the context of commercial vehicles like trucks and buses. And basically, we have, in Europe or US, in the Western countries, there are lack of truck drivers, or else there is highly paid truck drivers. So it is difficult to hire truck drivers in those countries, and there is low margin. The profit percentage of the fleet market, like there are basically the fleet is like where there are too many volume of trucks which is owned by a owner. So they are facing resource crunch, as well as they are facing a very low margin. And the sustainable transport, coming to the fuel efficiency as well as wear and tear of the vehicles, when we use drivers, there are lots of challenges in that. And most importantly, above all, there are more number of fatal accidents, like that could either end up in a loss of lives, or else that will end up in let's say injuries to either pedestrians or traffic participants, or to the drivers and co-drivers. So this is the strong push for ADAS, and these are all the some challenges. And so I will start with something very basic. How does this ADAS and autonomous driving technologies evolve? If you look at the left side of the let's say presentation, in the conventional vehicle, it is the driver whose responsibility is to look at the environment, who have to see, who have to think, and who have to react to the environment. Let's say if some vehicle is coming in front of you, it is the driver perception who has to see, who have to think and react to such that I have to apply brakes, or else I have to accelerate, I have to press a honk, something like that. And the driver is looking at the environment and he has to react to the vehicle, he has to give input to the vehicle. But if you come to the rightmost part of the presentation, you can see in the complete autonomous or a level 5 autonomous vehicle, you can see it is the ADAS systems or the technologies which will look at the environment, let's say be it camera or be it radar or be it LiDAR. These are all the conventional sensors used in ADAS world. and these sensors will be looking at the environment, and they will give the input to the vehicle systems to apply brake or give the warning to the driver, or take control of the steering for some time, something like that. So this is like a fully autonomous vehicle. Coming to ADAS, this is like one step transition before going to the ADAS. I think now at least you guys will be aware of, like there are some cars which are launched in India, like MG Aster, Honda City, Mahindra XUV 700, which you have seen in the internet. Like there are a lot of ADAS technologies like adaptive cruise control, forward collision warning, lane departure warning. There are a lot of features available, at least coming let's say within less than a period of 3 to 5 years. The awareness is getting increased. So in when I say about ADAS, these are like some intermediate let's say level of autonomous, be it level 0, level 1 and level 2. These are all the kind of features where we have to transition before going to a level 3 and level 4 and level 5 autonomous vehicles. There it is the driver who is responsible to look at the environment, but these ADAS features will assist the driver to give the warning, or to sometimes it will take control of the brake for some duration or something like that. So I'll explain that. As I say, it is not that easy to transition to a complete autonomous vehicle. There are a lot of interface changes which OEMs, truck manufacturers, bus manufacturers, they have to do a lot of changes in their braking systems, and a lot of vehicle interfaces. At the same time, we also need a infrastructure ramped up to that way. So the complexities increases. So coming to the basics of autonomous driving, so these are all the 6 levels of automated driving as per SAE J3016. So if you see the leftmost part, it is like the conventional vehicles without any assistance, our normal vehicles which we drive in day to day. And this is the level 5, is like, it is like brains are off and driver can be relaxed and he don't need to take control of the vehicle. It's like fully autonomous vehicle. Okay. So how does this transition will happen? If you see level 0, driver is alone and he has to take control, and assistance level 1, as I said, there are certain features like, for example, adaptive cruise control, stop and go, adaptive cruise control, which will take control of the vehicle for some duration in highways. So this is a kind of level 1 feature, but you cannot say AEBS. What do you mean by AEBS? Automatic emergency braking system, which will look at the environment. If driver is inattentive, or he is drowsy, or he has slept for a while or something like that, let's say it is that feature which looks forward a target, and then it will provide a warning, and then over a period it will just apply brakes and it will try to avoid the accident or else minimize the impact of the accident, something like that. Okay, but this does not come in the level 1, but because it is taking control of the vehicle only for quite some time. But for ACC, which is taking control for a while, so it is a level 1 feature. And this is just an example. There are a very big list of features in ADAS. And coming to the level 2, it is like partly autonomous. For example, as I said earlier, adaptive cruise control is one such feature which takes control in the longitudinal movement of the vehicle for quite a long time. And for example, there is a feature called as continuous lane keep assist. If driver, let's say, unintentionally want to take lane change, and if there are potential chances of accident, it will pull back or something like that. Means it takes the ADAS systems take control of the steering system also. When both these features are merged or something like that, an adaptive cruise control as well as a continuous lane keep assist, like lateral control as well as a longitudinal control features are merged together, this will come to a level 2 autonomous. So it is not that easy to mix two functions as simple as that. There are complexity associated with this. And so as of now, whatever technologies are, at least the recent list of cars whichever launched, the MG Star or Honda City EV or XUV 700, all comes with the level 0 and level 1 features only. And until level 3 features, I can say driver is responsible. Of course, ADAS is there to assist you, but driver is still responsible for let's say the situation happening in front of vehicle. ADAS will just assist you. But for level 4 and level 5, driver can be relaxed a little bit, and the technology will take control over the vehicle. Yeah. So before suddenly I am directly jumping into the topic, so I just wanted to touch upon back and forth. So for example, what is the push for ADAS globally is like, for example, in European Union, there is a commission called as United Nations Economic Commission for Europe, UNECE. The countries in Europe come together and they have formed a regulation such that all these 6 features have to be part of a truck and bus from 2024 onwards. Like any new vehicle which is going to get registered in Europe should have mandatory of all these features. Before somewhere in 2019 or 2020, European Union has mandated only 2 ADAS features to avoid fatalities or accidents in the roads, like ADAS, like automatic emergency braking system, and lane departure warning. And this has brought down the accidents to some level. Now we call it as general safety regulation, GSR 2.0, which is going to get mandated in Europe, and almost all the let's say OEMs in Europe or the OEMs in other countries which are exporting the truck to Europe should have these features as a part of mandatory. So one is blind spot information system. It is like whenever a person, a pedestrian or a bicyclist, we call them as a VRU, vulnerable road user. So if they are coming in the blind spot, it is the responsibility of the system to give warning so that a collision is not going to happen. And driver drowsiness and alert warning, I hope the name itself indicates. So whenever driver is drowsy, the feature will give a warning to take a coffee break or something like that. And intelligent speed assist, so we use a camera based function generally to detect the traffic signs, and if the driver is over speeding or crossing the speed limit of that particular highway or something, let's say it will provide warning to the driver, and over the period sometimes it will also apply brakes to reduce the speed of the vehicle. And of course tire pressure monitoring system is not a part of ADAS, but still it has to be mandatory as a part of the GSR package, whose purpose is to detect the tire pressure and has to warn the driver whenever the pressure drops down or something. And moving off information system, it is similar to a blind spot warning system. In case of blind spot, the driver who is sitting on the right side of the vehicle will have more blind spot in the left side, so that whenever a bicyclist or someone who is coming in the left side, it will give warning. But for moving off information system, as the driver is sitting very high from the ground, so even someone in front of you in traffic signals or something like that, it is difficult for them to look at the bicyclist or someone who is in front of your vehicle. So this is one such feature which warns there is a person, so do not move away, something like that. And reverse information system is about a person who is coming at the behind. We have to warn the driver, because the trucks are basically it is not applicable for a truck with a trailer, but it is applicable only for the rigid or construction kind of trucks. So now I am coming back to the basic, like these are all the conventional sensors used in the ADAS world. So one is a radar, one is camera, and when I say radar, there are different radars like long range radars, medium range, short range radars. What do you mean by range? In the sense, the ability of a radar to detect objects in front of you. For example, long range radars will have detection capacity until 200 meters. For a short range radar, it will have detection capacity until 30 or 50 meters, something like that. For a mid range, it's something in between. So depending upon the purpose or depending upon the feature, we can use the kind of sensor we wanted here. So I'll explain about the pros and cons of each sensor. And when I say about camera, of course, when compared to radar, let's say radar does not know day or night or something like that. Radar works by the principle of Doppler effect. It will sense radio waves, and I know how at least basically how a radar works. It just sends radio waves, and it will touch upon the object, and part of it is reflected back continuously for every radar cycle. This is this keeps on happening. So based on that, the radar will cluster an object and it will identify this as a relevant object for us, so that we have to apply brakes, we have to accelerate, something like that. But it does not have its own eyes. Radar is visually blind. That's the purpose we go to a camera. Camera has its own eyes, it can see and confirm. And see, in the sense, for example, a radar cannot detect a lane marking in the road. Okay, for features like lane departure warning, we need a camera. So, and for if you have to detect traffic signs at the side of the road or on the top of the highway, you need a camera. You have to visually see and confirm. And again, So it doesn't mean that camera is best when compared to radar. Camera is also having its own. So when we are driving highway, even we have that issue, right? When we drive in front of sunlight, we are get blinded by the sunlight sometimes, and when we drive in the night time, we get blinded by the high beam of the light which is coming in the front. So the same issue is happening with the camera also. So that's the reason sometimes automotive OEMs, so they go for a fusion system, or at least for the vehicles which are launched in India, fast cars especially, they use a radar system. And let's say I'm happy to also reveal one more information, like ZF being a pioneer in ADAS. So we are the first to launch ADAS in a commercial vehicle, let's say for Tata Motors in India with a radar only system. So but when I say about the complexity in a passenger car, we need a fusion system. The same complexity is very high in a truck. That's the reason all the OEMs are pushing towards a fusion system. And here okay, the main difference between radar and camera is I think the cost also matters. Basically the OEMs, they can fix all these sensors and they can use integrate all the functions in ADAS. But the challenge also comes with the cost. If there are more the number of parts you are integrating into the vehicle, the complexity is also, let's say the cost of the vehicle is also increasing. So OEM has to optimally choose the choice now. And then over the period, they also have to increase this, there are also other challenges like cyber security threats and all. So they have to evolve the braking system, so that they have to, whenever the system is requesting for brakes, unlike a driver, it should not under brake or over brake or something like that. So this technology also has to be evolved. And LiDAR, relative to camera, and unlike a camera or a radar, LiDAR uses a light wave to send it back. Almost it has the range similar to that of a radar, but LiDAR is extremely good at object edge precision or something like that. There are chances that when two objects are going closer, radar has if the antenna is not that good, there are chances that two objects may be considered as a single object by a radar. But when it comes to a LiDAR, it detects the object edges very precisely, that you are going as much closer. So, and when we use a 360-degree LiDAR, it virtually generates a map surrounding your vehicle, similar to that of a GPS, as you have seen. So yeah, these are all the three most used sensors in the ADAS or autonomous vehicle world. And when I say about ultrasonic sensors are used for very low range, like 0.5 to 2 meters or something like that. When we use in our pass cars, we have this reverse warning. Whenever we take a reverse or when we go closer to a wall or vehicle, it will warn, right? So we use those kind of use cases. We use ultrasonic sensors. And yeah, so of course the mix and match of these sensors play a key role. When we fix, we wisely have to choose the systems around our vehicle so that all the features can be integrated. For example, in the front of the vehicle, you need you need to use radars which are of very long range, so that you can be able to detect the vehicles which is coming too far at 200 meters also, so that we can use some integrate long range radars or camera or something like that. And similarly at the side, you need to cover the complete 180 degrees, so that you need to use a lot of you can also use camera, you can use short range radars, mid range radars, and then almost you can integrate in whatever architecture which you use. So this is so that's it about the sensors used in ADAS world. And I think these are like very basics. I'll touch upon one or two features. I hope you all know about this level 0 features, like lane departure warning, ABS. At least you would be little bit aware. Maybe I'll just explain about, for example, maybe traffic jam assist. I will take a level 2 feature, as I said earlier, or a highway assist. So it is basically the integration of both lateral control as well as the longitudinal control feature. Like it will take also the control of steering whenever you are departing a lane unintentionally, like without putting an indicator, and it will also take control of the vehicle whenever you are like when you need an acceleration or when you need a braking, something like that. And let's take a passive lane change assist. Whenever we are taking lane change in a highway, basically this does not take control of vehicle. It is a level 0 feature. It will assist you. If some vehicle is coming in the blind spot area, whenever, though there are two outer rear view mirrors in the side of your vehicle, this particular feature warns you when you are about to change. It will understand your intention of drifting from the lane, so that if there are a potential chance of collision is going to happen when some other vehicle comes in front of you, in the side of you, it will warn the driver. Basically, the operating speed of the vehicle will be from 20 to 125 kmph. But for a blind spot, with the same feature, let's say the same sensor set can be used for a feature like blind spot, but there the difference is the operating speed will be 0 to 25 kmph in kind of cities, especially in Europe, the cities like Amsterdam or Netherlands, where there is a very higher bicycle density. This feature is even, let's say, there are incentives by that particular regional government to implement in the vehicles. So basically, I explained in the past, like the purpose of implementing ADAS in Europe is that there is a general safety regulation coming in place. I know the slide is a bit complex, but I'll try to follow me. I'll try to make it as simple as possible. For example, you can see here items A, items B, C and D. There are a bucket of features in items A, bucket of features in items B and C and D. So from 2022 onwards, these are all the features. The features in the item A has to get mandated, and every OEM has to homologate those features, and every OEM should have those features as a part of mandatory package. And moving forward, so gradually all these features has to be, so when all these features are integrated together, then only we can be able to advance to level 3 and level 4. And Europe is also having an let's say vision of vision zero accident until 2030, so that as of now, after implementing this, let's say currently there are at least 1 million road accidents happening in Europe, and moving forward they are aiming for a zero road accident by 2030 onwards. So one such mission, so these are all, when all these features are integrated, so it is highly assumed that these road accidents or fatalities will reduce. So this is about Europe, but what's there in India? In India, government is working on implementing ADAS features. As of now, it is under table of, let's say it is with the table of ministry that there are some regulations are going to implement in India. Also for commercial vehicles, even when past cars are, just now they are implementing the ADAS features, commercial vehicle world is also implementing, is going to get implemented ADAS. I most likely believe after the upcoming elections, the news will get rolled out. As I said, what are all the challenges to implement in India? There are, let's say, the most predominant challenges like traffic and driving pattern. One is heterogeneous traffic. What do you mean by heterogeneous traffic? Like there are different kinds of vehicle on the road at the time, such that it is challenging for that sensor technology to detect it. For example, a radar may not be able to detect a auto, a tricycle. Sometimes, in case of Europe or US, you cannot detect a bicycle in a highway. But here you can have a mixed traffic density. There are bullock carts, there are vehicles which are loaded beyond its vehicle width, and there are vehicles which have loaded beyond its vehicle length. Let's say this protruding rods in the truck, in the second image where you can see, this is a challenging for technology like radar to detect it accurately. There are chances of, and what is the challenges? There are too many false positives going to happen. What do you mean by false positive? Like there is literally there are no target vehicle in front of you, like a potential collision target in front of you, but still you are providing a warning. So this will create an annoyance for the driver. Thereby driver will switch off the features in the vehicle and he will drive. So all this for this an extensive detailed mileage collection has to be done in India to understand such steps. And let's say the driving pattern is such that people will follow very closer, we will tailgate the vehicle bumper to bumper and we will take overtaking in highways. So this is also susceptible to rear crash. And there are challenges in lane disciplines also, let's say, because of which, as I said earlier, the false positives will increase. And coming to the vehicle causes, the most important part of implementing features like ADAS is like there must be a brake lamp, the brake lamp which should have at least, even before the ADAS will take control of the brake system, the brake lamp will get switched on at least let's say 1.5 seconds before the start of applying brakes, so that you are giving sufficient time for the driver who is coming at the rear, so that he does not come and hit you. When suddenly an ABS applies brake for a high deceleration like -5 or -10, let's say let's say your ABS is can avoid an accident in front of you, but what happens, someone who is coming in at the back of you who does not have that braking capability. So it is the responsibility of the technology provider to give sufficient reaction time for the driver who is coming at the rear, so that the brake lamp should be functional. And here in India we are not maintaining the brake lamps properly in commercial vehicles, especially during RTO registration or this what we call it as FC. We have those as functional, then over the period this will get deteriorated. That should not be the case. And there are integration gaps in the vehicle, like the braking system capability should be improved. It should be able to apply high deceleration, and it needs technology like electronic stability control even during driving curves or highways. It should not affect the stability of the vehicle. So these are all certain challenges which industry is overcoming, and it gradually it is getting sorted out. And coming to the traffic infrastructure, so there are non-functional traffic signs, deteriorated traffic signals and stuffs like that. So these things also needs to be improved, because there are ADAS features like traffic sign intelligence, intelligent speed assist, and traffic light intelligence. So for those features, these things should be conventional. It should be working. At the same time, we have something called as Vienna Convention. So for each and every roadside syndrome, for example, it may be speed limit signs, or it may be school ahead roads, and we call it as explicit or implicit traffic signs. So for those traffic signs, it should the dimensions, the color, or the reflective material which you are using, it should be. So we are also having a challenge more than that. So that also has to be addressed. And lane marking quality in the road, if there are no lane marker, there are chances of false positive, or we may provide unnecessary lane departure warning in the road. And yeah, there are high variance in the lane with India. Let's say as of now, whatever you are seeing in the roads are with the level 0 and level 1 features only. When we go to level 2, there are very, very high, complex and challenging scenarios. Yeah, and certain other factors like climate and route conditions, this also has to be taken in consideration while developing these features. And the technology is evolving with respect to collecting data, public road field data from those routes. So I think that's it. So thank you. Any questions? And don't consider any question. Thank you.